Welcome, and tonight we'll be talking about the half-angle formulas. As you see in the box here, we have a sine, cosine, and tangent, and then using reciprocals of 1 over sine gives us the cosecant, and the 1 over cosine would give us the secant, and 1 over tangent would give us the cotangent of these half-angle identities. Now again, you're not memorizing these, you're just going to put them to practice. Now note over here we have a couple possibilities for tangent x over 2, or the half-angle of tan 2. Half-angle because we see that they're all divided by 2. Likewise, yesterday we talked about double angle identities where it was like sine 2x. So let's look at some examples of what we're going to do with them. So if we have a sine of 105 degrees, the first thing we want to note is what quadrant this is in, or what coordinate. And so we find out that that is in quadrant 2. Sine in quadrant 2 is a positive number. So it is a positive number. If we look at the cosine, well, that is also in quadrant 2, but in this case, the number will be negative. The value will be negative that we find, and positive in sine. Now, here's how we proceed. We're going to look at this and determine what is this value 1/2 of. So in other words, 1/2 of what would give us 105. And hopefully you see right away that the answer is 210 degrees. That would be 210 degrees. So what we should be seeing here is a sine of 210 degrees divided by 2 is our half-angle identity. So we substitute that in for our radical of 1 minus, and in this case it's a cosine of that 210, and that is all over 2. At this point we will solve or simplify, giving us 1 minus the fraction, well, 210 on your trig chart will show up as a radical 3 over 2, and that is all over 2. Taking it one step farther, we'll see that we have the radical symbol of 2 plus radical 3 over 2, all divided by 2. Now this is all under the radical, and so we end up with 2 plus radical 3 over 4 is what we have under our radical. Now that is nearly our answer. However, we may want to see this as a radical of 2 plus radical 3 all over 2. That is because this would be a radical 4, which gives us the value of 2. Now let's take a look at our cosine. Oh, got a little carried away there. If we take a look at our cosine, it is in quadrant 2 and it's negative. So when we're working with the cosine, we're going to use the cosine of the half angle of 210 degrees all over 2 will equal, I'll choose to use the negative value because that's what its symbol is, and that's very important. We always find these quadrants. This is then the radical of 1 plus cosine 210 degrees all over 2, and then doing our simplification technique as we had on the previous problem, we get a very similar result. That will give us then 2 plus radical 3 all over 4, and then finally a negative radical 2 plus radical 3 all over 2. Again, notice this is negative and this one is positive. Now I didn't write the positive for this here, but it is definitely a positive value. Okay? These last two examples from this section 5.5 are solving the following equations using our half angle identities. So starting with 7, we see that we have a 2 negative sine squared x equals a 2 cosine squared of x over 2. Now, the x over 2 here we could rewrite as 2 cosine x over 2 all squared. That means the same thing if you recollect from earlier lessons. So here's how we're going to do this then. We'll leave the left side unchanged. Working with the right side, I now don't have a restriction on which quadrant I'm in, so I'll have to consider both cases, positive and negative, of 1 plus cosine x over 2. That is my formula. And again, this is squared. And so we're going to be squaring that side. Again, the left side remains unchanged. As I square this, I see I will have 2 times. Now the square will undo that negative, so I really only have one problem now of 1 plus cosine x all over 2. At that point in case, I'm going to cancel or reduce the 2's, leaving me with the 2 minus sine squared x on the left, 1 plus cosine x on the right, and now I'm going to come up with a common function. So I will change the sine squared x to its value of 1 minus cosine squared x, which really gives me 2 minus 1 plus cosine squared x equal to 1 plus cosine x. Now at that point I'm going to get everything to one side. I'll acknowledge first that that is simply a 1. So I'm going to bring everything over to this side, which means I am subtracting a 1 to cancel this out. Well, a 2 minus 1 gives me a value of 1. I am then going to subtract a cosine of x, and when I subtract my cosine of x, I do not have a like term, so what I am left with is then a subtraction of cosine x and a plus cosine squared x, all equals 0. It might have been best had I wrote this in descending order, so I'll rewrite that. And now I will factor. Factoring out a cosine x, which is the GCF, leaving me with cosine x minus 1 equal to 0. That tells me that I have a cosine x equal to 0, or I have a cosine x equal to 1. Where does this happen? Well, this happens at 0. It also then will happen at pi over 2 and 3 pi over 2. So those are my 3 exact answers for this problem. Sorry, getting a little tired here, so we're going to pick up, get all spontaneous, do a few jumping jacks. I know you can't see me doing those, but I am right now. There we go. Okay, we're all set. The cosine squared x will remain. I'm going to now solve for the double angle, seeing this again as a sine x over 2, and this will all be squared. So I have cosine squared x equals my plus or minus in the radical, a 1 minus cosine x all over 2, And again, this is all squared. Well, squaring this right side simply gets rid of the negative and the radical, leaving me with 1 minus cosine x all over 2 equal to cosine squared x. Now I like this because everything is in terms of cosine. So what I really have is a 2 cosine squared x equals a 1 minus cosine x once I multiply each side by 2 to get rid of that 2, or the fraction form. This will give me then 2 cosine squared x plus cosine x minus 1 equals 0 when I bring the 1 and the negative cosine to the left side. Is this factorable? Well, of course it is. They want us to have great success, so they make it nice and factorable. So I get a cosine x and a 2 cosine x to give me the first term. I now need my negative 1 term, which will give me a middle term of positive cosine x. So I have a plus 1 with the cosine x and a minus 1 with the 2 cosine x. Again, this is set equal to 0, and it is telling me that I will have the values of a cosine x equal to 1/2. Where did that come from? Remember, it's opposite of the negative 1 divided by the 2. Over here, then I will have cosine x equals negative 1, opposite of that 1. Where does this happen? It happens at pi over 3, 5 pi over 3, and the cosine of negative 1 is at pi. So there are my 3 answers, and you can then give a sigh of relief as we are done with this section's notes. So tomorrow we'll have a new assignment and do some work time with that. Thank you.